Okay, in the last chapter we have learned about mole concept, mole being a unit of quantity, and then we learned 4 different ways to find number of moles of a substance. So in this chapter we're going to extend further to use number of moles to perform a series of chemical calculations. But first let us look at a simple problem sum. So there's this village where each cat is capable of catching 2 mice a night. So based on the picture shown, how many mice were being caught? Now I'm sure many of you all will be able to get it that there are 6 mice that are being caught. And how do we know? It's because from the picture we can tell that there are 3 pairs of eyes, which tells us that there are 3 cats in the bush. And since each cat can catch 2 mice, in total there will be 3 times 2, so 6 mice that will be caught that night. Now how do we extend this to chemistry? Now let's look at this sample reaction over here. Magnesium reacts with hydrochloric acid. Now we have learned in the topic of acids and bases that when a reactive metal reacts with an acid, we get hydrogen gas and a salt. Okay, now the question is this. We were told in the previous question that each cat can catch 2 mice. Alright, but in a chemical reaction, how do we know that 1 mole of magnesium can react with how many moles of hydrochloric acid? Similarly, 1 mole of magnesium can produce how many moles of H2? How do we tell the relation? Now actually we have already learned it. We can actually tell the relation from the balanced chemical equation. Okay, so what do I mean by that? Now this is the balanced chemical equation for the reaction between magnesium and hydrochloric acid to produce magnesium chloride as the salt and the hydrogen gas. Alright, so how do we tell the relation? For example, 1 mole of magnesium can react with how many moles of hydrochloric acid is from the number in front of each substance. Okay, remember when we were trying to balance a chemical equation, we have to add a number in front of each substance if the number of atoms for that element is not balanced. Right, so the number here will be 1, 2, 1 and 1. Now, so what do the numbers tell us? The numbers tell us the ratio in which the substances react. Okay, so what do I mean by that? From the balance equation, I can tell that 1 mole of magnesium will react with 2 moles of hydrochloric acid. And when 1 mole of magnesium reacts with 2 moles of hydrochloric acid, it will produce 1 mole of magnesium chloride as well as 1 mole of hydrogen gas. Okay, so the relation, like for example in the previous example, one cat can catch 2 mice. So in this case, from the balanced chemical equation, we can tell that every mole of magnesium will require 2 moles of hydrochloric acid for a complete reaction. Okay, so again, from a balanced chemical equation, we can tell the ratio in which the reactants react and the ratio in which the products are formed. So this ratio is known as the reacting ratio. The reacting ratio in a chemical reaction is also given a special name. It's called stoichiometry. Okay, stoichiometry. So when we ask for the stoichiometry of a chemical reaction, it means the ratio in which the reactants react and in which the products are formed. Now this is an example of a chemical calculation question that you will need to learn to solve. Alright, so in this equation we are looking at the reaction that we have seen before, magnesium reacting with hydrochloric acid. So in the question tells you that I have 12 grams of magnesium undergoing reaction, and the question requires you to find out what is the volume of H2 that was produced. Alright, to solve chemical calculations like this, there is a 3-step approach which we are going to look at. This is the three-step approach, okay, which I call it the 3C approach. So the 3C's are: number one, convert whatever that's given in the question to moles. Next, we need to compare the mole ratio, which is also the reacting ratio. And lastly, we need to convert from moles to whatever that the question wants you to solve. Now, I know it sounds very abstract at this point in time, but just bear in mind the 3C's for now. When we are solving it, it will become obvious to you what the 3C's mean. Okay, so back to the question. Now we'll apply the 3C approach. The first C is to convert to moles. Right, convert whatever that's given in the question to moles. So let's look at what is given in the question. We are given 12 grams of magnesium. So now we need to convert this to moles, meaning we need to find number of moles of magnesium, which is equals to, since we are given the mass, if you can recall from the last chapter, we take the mass divided by the molar mass, which is 12 over 24, and we get 0.5 moles. Okay, step number 2, compare mole ratio. Okay, so which ratios do we want to compare? We want to compare the mole ratio between what is given and what we want to find. Okay, what do I mean by that? What information is given in the question? We are given the mass of magnesium, so this is what is given. What do we want to find? From the question, we know that we want to find volume of H2. So we need to compare the mole ratio between magnesium and hydrogen. How do we compare the mole ratio? We look at the number in front of the substance, and since there's nothing there, it means 1 is to 1. What does it mean? It means that 1 mole of magnesium will produce 1 mole of hydrogen gas. Okay, so using the reacting ratio, we can actually find number of moles of hydrogen. If 1 mole of magnesium produces 1 mole of hydrogen gas, 0.5 moles, there are 0.5 moles of magnesium present, it will produce the same number of moles of hydrogen gas. Okay, so this is step number 2. By comparing mole ratio, we can find the number of moles of hydrogen produced. Now, step number 3 is to convert from moles. If you look at the question requires the volume of hydrogen, not the number of moles. So now, after finding number of moles of hydrogen, we need to convert it to whatever that's required in the question. And how do we do that? Since they want volume, you need to recall the relevant triangle to use. Okay, so using the triangle, we can find that the volume of H2 is equals to number of moles times 24 dm cubed. Okay, so that will give us 12 dm cubed. Now let's try to use the 3C approach for 2 other questions so that you become very familiar with the steps. So in this question, we are looking at the formation of sodium chloride by reacting sodium with chlorine. Okay, since the chemical equation is not given to us, you are expected to write out the equation. So sodium plus chlorine gives you sodium chloride. Now for this question, very often, okay, so this is the balance equation. Very often students will forget that chlorine is a diatomic molecule, so they will write something like this: sodium plus chlorine gives you sodium chloride, and that will be wrong because you'll be using the wrong reacting ratio. Alright, so please bear in mind that there are certain molecules that are diatomic. If you have watched the chemical bonding videos, is have no fear of ice cold beer. These molecules are diatomic. Okay, so after writing the equation, let's apply the 3C. Okay, first C is to convert to moles. So look at what is given in the question. We are given the mass of chlorine, so we need to convert it to moles. Number of moles of chlorine is equals to mass over molar mass. Okay, so 1.42 divided by 35.5 times 2. Okay, that will give us a value of 0.02 moles. Okay, so this is step number 1, convert to moles. Step number 2, compare mole ratio. Okay, compare mole ratio between what? Between what is given. So we are given the mass of chlorine and what we want to find. What do we want to find? We want to find the mass of sodium chloride. So what is the ratio like? The ratio is this: 1 mole of chlorine will give me 2 moles of sodium chloride. Okay, so from the mole ratio we can now find number of moles of sodium chloride. How? If 1 mole of chlorine produces 2 moles of sodium chloride, 0.02 moles of chlorine will produce 0.02 times 2, which is 0.04 moles of sodium chloride. Okay, now we'll go on to step number 3. Step number 3, we need to convert from moles. Alright, the question requires you to find the mass of sodium chloride. Okay, what we know is the number of moles of sodium chloride, so we take the number of moles multiplied by the molar mass, which is 23 plus 35.5. Okay, and that will give us a value of 2.34 grams. Okay, so this is the second time that we see the 3C approach in action: convert to moles, compare mole ratio, and then convert from moles. Let's look at another practice. So in this question, we have the reaction. The equation is already given to you. It's the decomposition of sodium hydrogen carbonate to form sodium carbonate, carbon dioxide, and water. Okay, so let's try to apply the 3C approach since the equation is already given. So step number 1 is to convert to moles. So what is given in the question? We are given the mass of sodium hydrogen carbonate. So how do we find the number of moles of sodium hydrogen carbonate? Again, is by taking mass divided by molar mass. Okay, so we take 16.8 divided by the molar mass of sodium hydrogen carbonate, which is 23 plus 1 plus 12 plus 16 times 3. Okay, that will give us a value of 0.2 moles. Okay, so step 1, convert to moles. Step 2 is to compare mole ratio. Compare mole ratio between what? Between what is given, which is sodium hydrogen carbonate, and what is formed, which is between what is given and what is what we need to find. So what do we need to find? We need to find the mass of the solid product. If you look at the state symbols of the products in the equation, the solid product means your sodium carbonate. Okay, so what does the mole ratio look like? It looks like this: 2 moles of sodium hydrogen carbonate will produce 1 mole of sodium carbonate. Okay, so number of moles of sodium carbonate will actually be equals to half times 0.2, which is equals to 0.1 moles. This is step number 2. Step number 3, we need to convert from moles. Okay, since the question requires the mass of sodium carbonate, now we have number of moles, so we need to convert to mass by taking number of moles times the molar mass, and that will give us a value of 10.6 grams. Okay, so I hope by these 3 questions you'll be able to see that how to use the 3C approach in solving chemical calculations. Okay, always remember the 3 steps: convert to moles, compare mole ratio, and convert from moles. That will allow you to solve 90% of chemical calculation questions.